Okay, we're back, and basically I got the cover back on the panel, and we turned on the 30 amp 480 volt breaker. I have the breaker off here so the power is not sent over by the kiln. Well, I just wanted to test the transformer, and what you want to do, these here are the 3 hot legs here, A phase, B, and C. Now across any one of these terminals we should get 208. So I have a meter here. You can see it. Right now it's on the 0. When I go across any 2 legs, I'm going to go across the A and B phase. We get 210. Okay, that's very good. It's supposed to be 208. That would be if it's exact. 2 volts off, that's absolutely nothing. That's fine. Okay, now we go across the B and C phase. 210, perfect. And then we'll go across the A and C phase. A and C. Here we just got a little bit higher, 212. Okay, but again, that's fine. If this was for some computer equipment, we may be able, we could change the taps. There's taps in there to actually bring the voltage down. That's what those little silver things sticking out of each coil. We could change those. Take a wire off. Yeah, take that wire off there, and you put it down in the middle in there. But you know what? For the kiln, that's more than enough. Actually, we're going to take a voltage reading on the receptacle down there. We might even lose a volt or two because of the distance. We got about 100 feet of wire going over that way. But we're absolutely perfect. Right where we want to be. Here's your ground wire. It has to be hooked up. Okay, that's your neutral tap. The kiln does not take a neutral, but we do still have to ground it. That's considered our grounding electrode conductor, which has to be bonded to the building steel. So it goes from here, and then on the other side of the transformer, here's my bonding wire. And that has to be sized appropriately. You look in the code book under bonding electrode conductor, and that would be it. Going up, and I close the ceiling up, but it's bonded to the building steel. Okay, we're back here at the art room at Fallon, and I just wanted to show you the completion of the installation of the kiln. They're actually already using it now. I finished it up the other day. I came back this morning just to finish this, film a little bit, show you completion, and they're using it already, which is fine, which I told them they could do that. So I'll just show you really quick exactly what we did here. Okay. Kiln is set right here. And what I did is we installed a 50 amp receptacle. So if they want to quick disconnect it and move it, they could do that, which they will have to do when the summer comes and they have to strip the floors. This is the exhaust for the kiln. It was installed exactly the way the manufacturer suggested to vent it out. They actually supply you with the black hose on the floor. Then you have to go from their fan exhaust motor and duct it up into the ceiling, which is what we did, out into the roof. Here's the feed, and I just added this receptacle with a switch here. When the light is on, I don't know if you can see that, but the light is on right now. When I turn it on, the light will come on this way. They know that the fan is running, although you can hear it. Just something else I wanted to do, make it a little nicer. But that's the installation right there. And I also installed a disconnect here on the wall. By code, we didn't really need to do that, but I just like it as a safety feature. If there was ever a problem, for some reason the kiln had maybe caught fire or sparked, most people aren't going to go over to the plug and pull it out if the thing is smoking. but it's important to kill the power to it, so this way they can come over here and can actually, grab the handle and shut it down. It's all marked. Breaker located in the gymnasium storage room, and just put down kiln disconnect. And it's all marked by the storage area too in the gymnasium. But that's the completion. James Fallon now has a new kiln in their art room.